Alright, so we are here with question 5 of the November 2018 South African CAP Syllabus Mathematics Matric Exam Paper 2. And this is a question on trigonometry. So let's write down a couple of things we know from trigonometry and then we'll use that in the questions to follow. So first thing we need to do is we need to obviously know our cast diagram. So our cast diagram just says the following: CAST for cast. And we know the degrees. This is 180 degrees starting at 0, 360. 180 degrees going this way is plus, so this quadrant is 180 plus, this quadrant is 180 minus, right? So we know from transformations and all of that, that clockwise is negative degrees and plus is anti-clockwise. And then this quadrant will obviously be 360 minus, going in that direction. All right. So this just says all are positive in here: cos, sin, and tan. Here just cos is positive, sin is positive, and tan is positive. The other things are negative in here. All right, we need to know that. What else do we need to know? Let's write down some of the identities that we know. We know that sine squared of a value plus cos squared of the same angle is equal to 1. We know that tan of an angle is equal to sine of that angle divided by cos of that angle. And what else will we need in this question? Here, plusing angles, so compound angles. We need to know that sine of an angle plus another angle is equal to sine A cos B plus cos A sine B. Cos A sine B. And I think that looks like all we need to know for this, and we need to know our special triangles. So let's draw our special triangles in. So our special triangles look like this. And let's draw another one like that. Okay, so if that's the 90-degree angle, let's say this is 30 degrees and that's 60 degrees. We know the ratio of the sides are 1, 2, square root 3. And we know the sides square, if this is 45 and 45 degrees, let me just rewrite that. If this is 45 degrees and this is also 45 degrees, then we have 1, 1 and square root 2. Okay, I think that's sufficient information for us to use for this question. All right, let's get to question 5.1.1. So 5.1.1. Here we have calculate the value of k. Okay, so we can see that point P is k1, so the x value is k, the y value is 1, and we know this distance is square root 5. And obviously this point is 0, 0, the origin. So we can just use the distance formula. So that's analytical geometry idea here. We know that the point OP, or the distance OP, is the square root of 5. So we can say that that distance squared, so OP squared, equals, and then we just do the distance formula for OP. So k, the x value minus the x value, difference between the x values, so that's k minus 0 squared, plus, and then 1 minus 0 squared, difference between the y values, squared. Okay, so square root of 5 squared is just 5, equals, not plus, my bad, equals, k minus 0 is k squared is just k squared, plus, and then 1 minus 0 is 1. 1 squared is 1. So we can take the 1 over, so 4 equals k squared, and we take the square root. So k is equal to the positive square root of 4, or k is equal to negative square root of 4. And we know this is in the second quadrant, right? They tell us second quadrant. So we know that the k value has to be negative, x has to be negative there. So this is our answer. This one does not count because that's not in the second quadrant. So k equals negative 2. Great, good start. 5.1.2. 5.1.2. Without using a calculator, calculate the value of tan theta. So we need to find tan theta. So whenever we have something like this, right? So this is our theta, but we can imagine this is theta. That will work because we can use the cast diagram to figure out what happens in the different quadrants. So we can always just say that angle is theta. Now, let's do this. Let's say, okay, we can make this into a right angle triangle. A right angle triangle. And then just use this as theta, and then use our cos diagram to account for the different quadrants. So we don't have to worry too much about the acute or obtuse angle idea. Okay, so tan of theta equals opposite over adjacent. So what is this value? This value is 1, right? So tan of theta is 1 over, and what is this value? Well, this distance is 2, but it's in the second quadrant, so it's -2, right? We know k is -2. So 1 over -2. And that's it. That's it. If we ignored the negative positive idea, if we just looked at this triangle, just like that, this distance is 2, that distance is 1, we'd say 1 over 2, but then we know 180 minus, we know it's in this quadrant, so we know tan here is negative, so we would just say -1 over 2 instead of positive 1 over 2. Okay, so that's how we can use the cos diagram. So tan theta is -1 over 2. That's for part A. Then for B, we need to find the cosine of 180 plus theta. So let's write cosine 180 plus theta. Now, let's look in our cos diagram. 180 plus, this quadrant, is cos positive or negative in this quadrant, in 180 plus? Well, cos is not, this is not a C, so cos is negative, right? Tan is positive there, cos is negative there. So we can say this gives us negative cos theta. Okay, and we can just read off the cos theta values here. So cos is adjacent over hypotenuse, so it's -2 over 5 for cos theta. So cos theta is -2 over 5, or root 5. And negative makes a positive, so it's +2 over root 5. Good. Question C. 5.1.2c. Okay, without using a calculator, find the value of sine of theta plus 60. I'm just going to write the question down again. Sine of theta plus 60. And we have to get it in the form of a plus b over root 20. Okay, so let's ignore this form first. Let's just calculate what we can from here. And now we've got some angle plus another angle. So we can use this idea, right? Sine of a plus b equals sine a cos b plus cos a sine b. So this will be equal to sine theta cos 60 plus cos theta sine 60. Sine 60. Okay, so sine theta, again we can read off the graph here. Sine theta is opposite over hypotenuse, so that is 1 over root 5. So sine theta is 1 over root 5. And sine is positive in that quadrant, so we just keep it positive. Cos 60, how do we know what cos 60 is? Oh, we can use our special triangles. Here we've got angle 60. So cos of this angle is adjacent over hypotenuse, so that's 1 over 2. 1 over 2. So times cos 60, which is 1 over 2, plus, then cos theta, we just read that, we didn't actually read that off. We can read it off here. Cos theta is -2 over root 5, adjacent over hypotenuse. -2 over root 5. So -2 over root 5. And then sine 60. Again, we can read that off here. Sine 60 is opposite over hypotenuse, so root 3 over 2. So root 3 over 2. Root 3 over 2. Okay, now we can just multiply. 1 times 1 is 1. 2 times root 5 is 2 times root 5. Plus and a minus make a minus. Negative, and then we've got 2 root 3 at the top. 2 root 3. And at the bottom we've got 2 root 5. 2 root 5. Okay, so we've got a common denominator, so we can just write that as our common denominator. And at the top we have 1 minus 2 root 3. Okay. Oh, I see my screen is flickering a little bit. Sorry for that. Okay. Now, this looks close to what we want, right? They said in the form of a plus b over root 20. So we've got an a plus b, but not over root 20. But the thing is, this is root 20, right? Because, well, let's first just write the answer. So we've got 1 minus 2 root 3 over root 20. Oops. Over root 20. Now let's see, if we take root 20 and we simplify that, we can say it's the same as the square root of 20 is 4 times 5, right? 4 times 5. And now, if we're multiplying, we can separate them out. Square root of 4 times the square root of 5. And what is the square root of 4? Well, that's 2. Right, so we can see 2 root 5 is just a simplified version of root 20. So if you didn't see that, what you could do is you could just use your calculator sort of as a bit of a trick. Just type this in your calculator, press equals, and it should give you 2 root 5. So then you can see, you already have this, and you just rewrite it as root 20. So that will be our answer. Okay, let's get rid of this and move on to the next question. So that was everything for 5.1.2. Now 5.1.3. 5.1.3. So use a calculator this time to calculate the value of tan of 2 theta minus 40. 2 theta minus 40. Alright. So tan of 2 theta minus 40. So first thing I see is I think we probably need to work out the value of theta first, and then we can just type that in our calculator. So how will we find the value of theta? Well, what is the first thing we calculated? We calculated tan theta, so we can just use that, right? We saw tan theta was negative a half. Okay, so we're going to say tan theta was negative a half. So we're going to find our reference angle. Reference angle is arctan, or shift tan in calculator language again, of 1 over 2. See, we ignore the negative. I did another video in one of the previous questions where we ignored the negative first. That's why we call the reference angle and not theta yet. We'll use the cast diagram to account for the different quadrants. Okay, so arctan of a half, and we get our reference angle is then arctan of a half. Let's do that. A tan of 1 over 2, and we get 26.565. Let's do 3 decimal places. So 26.565. So that's our reference angle. But now we saw that tan theta was negative. So in which quadrant is tan theta negative? Right? We're working in the second quadrant, and the second quadrant is 180 minus. 180 minus. So theta is then 180 minus 26.565. So that'll give us 180 minus this, give us 153.435. Well, let's just do 153.43. 153.43. 2 decimal places should be enough because we need 1 at the end. So if we have 2 here, that should be fine to round off to 1 at the end. So that is angle theta. Now we can plug that into our question here, which is tan of 2 theta, so 2 times 153.43 minus 40. And this is now just calculator work, so that will be tan of 2 times 153.43 minus 40. And it gives us 18.2 rounded off to 1 decimal place. So equals 18.2 rounded off to 1 decimal place. Great. Now 5.2. 5.2. Okay, so 5.2, solving an identity, we're probably going to need a bit of space. So let me move this out of the way. And let's just put that right here at the bottom. Just put that right there. Alright. So 5.2. Let's use some space here. Okay, prove the following identity. So first I'm just going to rewrite the identity. So we've got cos x plus sin x over cos x minus sin x. So cos x minus sin x plus, no minus, sorry, minus, and then cos x minus sin x at the top, and this time cos x plus sin x at the bottom. Plus sin x at the bottom. And we have to prove that that's equal to 2 tan 2x. So whenever we've got something that we have to prove, like an identity or something, then we just want to work with one side and keep the other side just as it is until it looks the same. So we're going to work with the left-hand side. It doesn't really matter. It's usually nicer. I just always start with the left-hand side unless it looks really complicated or difficult. Okay, so here we've got fraction minus another fraction. What do we know about adding or subtracting fractions? Well, we know we need to find a common denominator. So the common denominator here will be cos x minus sin x times cos x plus sin x. Cos x plus sin x. Right, just this times this. So that's our common denominator. Now at the top, This one was cos x plus sin x. Cos x plus sin x. So what do we need to multiply this fraction with? Right, we need to still multiply with it cos x plus sin x. It already has the cos x minus sin x, so we need to multiply it with this. That's exactly the same, so I'm just going to write squared. So cos x plus sin x times cos x plus sin x. Minus, and here we had cos x minus sin x. And we still have to multiply this with another cos x minus sin x. So I'm just going to write squared again. And on the right hand side, I'm just going to keep my 2 tan 2x. 2 tan 2x. Alright. Now we need to multiply this out, and that's why we need a bit of space. So if we multiply this bracket out, we'll get cos squared x, then plus cos x sin x plus another cos x sin x, so it's plus 2 cos x sin x, or sin x cos x. Doesn't matter which way around you write them. And then sin x times sin x is sin squared x. Sin squared x. Okay, now here we've got cos squared x, but it's a minus, so minus cos squared x. Then we've got cos x times negative sin x is negative sin x cos x, minus another sin x cos x, so it's minus 2 sin x cos x, but it's a minus minus, so it becomes a plus 2 sin x cos x, 2 sin x cos x, and then minus sin x times minus sin x is positive sin squared x, but there's a minus, so minus sin squared x, minus sin squared x. All of this still over this. So I'm going to multiply this out. To multiply this out, we get cos squared x minus sin squared x. So cos squared x minus sin squared x. And if you don't trust me, you're welcome to go multiply it out, collect the like terms, and see that it simplifies to this. Okay, on the right hand side, we've got 2 tan 2x. And now, let's collect the like terms on the top. So cos squared x minus cos squared x, okay, that's nothing. Sin squared x minus sin squared x, that's also nothing. Nice, it's looking quite nice. And we've got 2 sin x cos x's plus another 2 sin x cos x's, so that gives us 4 sin x cos x. 4 sin x cos x at the top, and at the bottom we've still got cos squared x minus sin squared x. Cos squared x minus sin squared x equals 2 tan 2x. 2 tan 2x. Okay. Now, we see here there's a 2 times something. So we can factor out a 2 here, or not really factor, but we can just rewrite this 4 as 2 times 2. So I'm going to say this whole thing is just 2 times, and then 2 sin x cos x, 2 sin x cos x over cos squared x minus sin squared x. Minus sin squared x. And you're welcome to skip some of these steps and just do more in one go. I'm just trying to do almost all the steps, except multiplying out, I skip a few steps. 2 tan 2x, not 2 tan x. Okay. And now, so these are double angle formulas. So that's something I forgot to write down at the top here. Let's add that in. So double angle formula, so if we have sine of 2 times something, that is the same as 2 times sine A times cos A. And if we've got cos 2A, we've got 3 options to write this. One option is cos squared A minus sine squared A, which is what we have in this question. Another option is 1 minus 2 sine squared A, and another option is 2 cos squared A minus 1. So these are double angle formulas. And it's also given in the formula sheet, so you can just have a look at that. Okay, so we've got these two, right? We've got that one and that one in our question. So let's see, how do we use them? So 2, and then 2 sine x cos x, we said that's the same as sine 2x. And cos squared minus sine squared, we said that's the same as cos 2x. Equals 2 tan 2x. Okay, and now we know that sine over cos, if it's the same angle, that's sine of 2x over cos of 2x, sine over cos is tan. We had that right at the top here. So tan of some angle is sine of some angle divided by cos of that same angle. So we've got 2, and then we've got tan of this angle, 2x. So 2 tan 2x equals 2 tan 2x. Perfect. Great stuff. And the last question. Oh, some sigma notation in trigonometry. I think that might be the first time I've seen that in a question. Let's have a look. So we've got the sum of, let me just write 5.3. So 5.3. So we have a sigma, so the sum of, and I think it was A, starting at 38, ending at 52, of cos squared A. cos squared 8. Let me just make sure. Cos squared 8 from 38 to 52 degrees. Perfect. Okay, so what does this mean? Well, let's just write on the first couple of terms to see what's happening here. So the first term would be cos squared 38, right? Plus, and then cos squared 39. And then we keep going. And none of these values are values that we know from special triangles until we get to 45, right? We know 45's value. So cos squared 45, let's write that down. And then we keep going. And the last two will then be cos squared 51 plus cos squared 52. Okay, so far we know this value. We know this value because we know from here, we know cos 45 is 1 over root 2. Alright, so now let's see, can we find something else here? Because we don't know cos 38, we don't know cos 39, so that's going to be quite difficult. But something else we also know. Let's write that down at the top here. Something else we also know. We know that, where will I write that? Let's write that over here. Sine of 90 minus x is equal to cos x. Right? So sine, if it was, so 90 minus x and cos x, so together these angles add up, they add up to 90 degrees. So if you have two angles that together make 90, then they are the same if one is sine and the other one is cos. For instance, sine 30 and cos 60. Right? These two together add up to 90, so they are equal to each other. And we can see in this case sine 30 we know is a half, right? Sine of 30 is 1 over 2. And cos of 60 is also 1 over 2, right? Also 1 over 2. So that works out. So that is something we'll use. We will definitely use that. Because, what can we see here? Well, we see 38, 52. That adds up to 90. Right? And 39 and 51. That adds up to 90. All of those will add up to 90 until we get to this one that's left here. Okay. So we can say, we can rewrite either cos in sin, or we can write these coses in terms of sin. So I'm going to keep these as cos. I'm going to say cos squared 38 plus cos squared 39 plus, and then cos squared 45 is 1 over root 2 squared plus, keep going, and then instead of cos squared 51, I'm going to say that's the same as sine squared. What is 90 minus 51? That's 39. Plus, and then again sine squared. What is 90 minus 52? That's 38. Okay. Now that's quite nice because we see the symmetry here. So we know this plus this is 1. Right? And then cos squared 39 plus sin squared 39 is also 1. Just in case you're wondering, we had that over here. Sine squared x plus cos squared x equals 1. Okay, and then we do that. So that's for 38, we've done that. For 39, for 40, for 41, 42, oops, I almost wrote 42, 42, 43, 44, and then cos squared 45. That's just 1 over root 2 squared, which is a half. Okay, so 1, 2, 3, 4, 5, 6, 7, 7.5. And that's it. So if you found any other way to write this down mathematically, let me know. You could have maybe arranged them as cos squared 38 plus sine squared 38. So that might be actually a nice way to do it. Let me just show you what I'm talking about there. We could have written, let's just circle this as our final answer. We could have written cos squared 38, so cos squared 38 plus sine squared 38. And then plus cos squared 39 plus sine squared 39. Sine squared 39. And then plus, until we get to cos squared 44 plus sine squared 44. And then just plus cos squared 45 as our last one. So then we know it's 1, 2, so that's 7 of those ones, plus cos squared 45 is a half, and then we get our 7.5. So that's fine, as long as you show the idea that you know cos squared 45 is a half, or cos 45 is 1 over root 2, and you know that the cos 38 is equal to cos 52, because cos 52 is sine 38. And so cos squared 38 plus sin squared 38 is 1. So that's going to be very useful. Okay, so that was then that for this question. I think, yeah, this is a good question, a fun question to do. Let me know if you use any other methods and any of the spots to find the answers, and I'll be happy to discuss that with you in the comments. I'll see you again for question 6.